Morning, everybody. We're going to start our next unit here on statistical hypotheses and testing for those. And so this is kind of related to the idea of correlation that we just got done with. So in correlation, you're either trying to prove that a relationship exists or it doesn't. So you're trying to verify whether something exists or it doesn't. And with hypotheses, you're trying to verify whether a claim is true or not. And so a lot of times you'll hear claims about from companies about, this product has an average of this, or 72% of people who use this have this effect happening. And so it's a pretty prevalent thing that we'll see. Now that I've mentioned it, I'm sure you'll notice it everywhere. But the example that we're going to use kind of to move forward while we're talking about statistical hypotheses as a manufacturer of insect repellent might claim that on average their product is effective for longer than 6 hours. And so in statistics, what we call this right here is we call this a statistical hypothesis. Now, obviously, anybody can make claims about anything. Anyone can make a statement saying, "Oh, mine is greater than this. The mean is this. The percentage is this." But to statistically prove that, you have to do what's called hypothesis testing. So now, there's three components to hypothesis testing here. So the first component of it is actually formulating your hypotheses. You're saying, okay, here are the two things that could be true. And that's what we're going to focus on in this first section of 16a. So then after you've got your hypotheses, you say, okay, this is what we believe to be true. We've got to collect some data, and then we've got to calculate some statistics to test our hypothesis. And after we collect that data and after we test our hypotheses, we have to make some decisions about the population based on what we see in those samples. So there's going to be a lot of vocabulary here just going over this, a lot of conceptual knowledge. So if you all have any questions on what something is, or if you're confused, feel free to join the Zoom and ask me. I do not mind to answer those questions. So whenever someone makes a claim, if a claim is made that a population has some value, well, we call this the null hypothesis. So this is like our status quo. And so the null hypothesis we represent with this right here. It's a big old H for hypothesis, and the null we just have H sub 0 or H naught. And so your null hypothesis is always going to be that the mean is equal to the mean sub 0. It's always a claim that the mean is something here. And this is like our status quo. The null is always assumed to be true unless someone has enough evidence to overturn it. So you have to run a statistical hypothesis test to overturn it. And so if we do not reject the null hypothesis, the status quo, we accept that the mean mu here is the same as mu sub 0 or as mu naught. And so all that the null hypothesis is saying is that the mean of this population is equal to what they're claiming it is. So if the null hypothesis is true, it just says that there's actually no difference between the mean mu and the mu naught that they're claiming here. And the important thing is claiming. We don't know factually that that's true until we conduct a hypothesis test. So with that, so if the null hypothesis here, if H sub 0 is rejected, if we find some proof that it is, we accept that there is a difference between the two here, between what they claimed and what it actually is. And if there is a difference, that's what's called an alternate hypothesis. If it is rejected, there is some alternate hypothesis that must be true because the null hypothesis was not good enough. It was not accurate statistically. So there's three types of alternate hypothesis that you could have. So if someone makes the claim that the mean is a certain number, like if they said that the mean was 6, some options that could happen there. The first alternate hypothesis, so we denote that with H sub 1. So the first alternate hypothesis could be that the population mean is actually greater than the mean that was claimed. And that would be a one-tailed, because if you shaded, so we are working with normal-ish type curves. We'll get to more of that in a second, but that would be a one-tail because that is referring to the right of a point. We refer to this as a tail. This is a one tail right here. So it could also be the case that not only is it greater than, there's another type of one-tailed test that says that the alternate hypothesis is that the population mean is less than what they claimed in the null. And that's going to give us a one-tailed again, except we're going to shade to the left of it. And then the third type that we have is we actually say, well, it's just not equal to the mean. And what that is that gives us a two-tailed, because that could be a less than or that could be a greater than. And since these curves are symmetrical, it could be either end. So because it is two-tailed, we have to shade both ends. And so what we're going to do is we're going to practice writing some alternate hypotheses here. And the alternate hypotheses that we're going to be going off of, we're going to be starting off of this first example in your all's books there. So a manufacturer of insect repellent might claim that on average their new product is effective for longer than 6 hours. So we're going to say that they're claiming it is equal to 6 hours. So what we're going to do is we're going to write a hypothesis for each of these, an H naught, which is our null, and our alternative here, if that is not correct, if that is not true. So H naught is always, so the first thing we're going to do, if a manufacturer of a new brand wants evidence that their product is superior in protection time. So the other guy said it was 6 hours. So the null hypothesis for them is that the mean is going to be equal to 6. And this new company comes along, and because the way companies work, and this being America, they want to have a superior product to them on the market so people will buy it. And so they want to write a test that says, okay, well, we claim it is superior. So think about, okay, which one of these alternate hypotheses would I write? So we're claiming here that the mean is just greater than 6. So all we're doing right now is we're writing some of these hypotheses, because this is the first step in doing statistic testing. And doing hypothesis testing, excuse me. So then another example here. If a competitor wants evidence that their product has inferior protection time, the way that we would write this is we'd say the null hypothesis is still going to be H naught is that the mean is 6. And we're saying that the alternate hypothesis here is that the mean, the population mean for them is actually going to be less than 6. So if we were going to put that in words, we'd say that this null hypothesis says the new product has the same protection. I'm just going to put protection, P-R-O-T, with the dot. I'm out of room. And the other one, the alternative hypothesis, is that the new product protects for less. And so the alternate is just a change in the status quo, or saying, well, actually, we're not sure that what they said is completely true. We're not sure if it's completely accurate. And so we're going to try one more of these. And so we've got a team wanting to show a new product differs from the old repellent. So if our null hypothesis here is still that the mean is 6, think to yourselves real quick, how would I do differs mathematically? If something differs from this null hypothesis, how would I write that? And we would denote that by saying that the mean is not equal to 6. So what I want you all to do real quickly, we're going to put a pause on the notes because I actually want you all to go and practice a few from 16a, because with hypothesis testing, the very first thing that we've got to be able to do is write a hypothesis. So we're going to put the brakes on for just a second, and then we will pick this up.